Hey there, science fans! Today we're diving into the exciting world of electromagnetism. Electromagnetism is a fundamental force of nature. It's all around us. It's responsible for everything from the electricity that powers our homes to the beautiful northern lights. Electromagnetism is all about the relationship between electricity and magnetism. They're like two sides of the same coin, inseparable and amazing. When electric charges move, they create a magnetic field. And guess what? A changing magnetic field can create electricity. We're going to explore this awesome force through some fun, easy experiments you can try at home or in the classroom. Get ready to be amazed. Our first experiment is a classic. It demonstrates the power of static electricity. Static electricity is what makes your hair stand on end when you rub a balloon on it. Let's get started. Materials: a balloon, a plate, black pepper instructions. 1. Sprinkle a small amount of black pepper onto the plate. 2. Inflate the balloon. 1. Rub the balloon vigorously on your hair or a wool sweater for about 30 seconds. 1. Slowly bring the balloon close to the pepper on the plate, but don't touch it. What happens? You'll see the pepper jump up and stick to the balloon. So, why does the pepper dance? It's all about static electricity. When you rub the balloon on your hair, it gains negative charges called electrons. These electrons are attracted to positive charges. When you bring the balloon near the pepper, the negative charges in the balloon attract the positive charges in the pepper. This attraction is strong enough to lift the peppercorns off the plate. Now let's create our own magnet using the power of electricity. This experiment shows how electricity can create a magnetic field. Materials: a large iron nail, about 3 inches long, a long piece of thin, insulated copper wire, about 3 feet, asterisk, a D-cell battery, paper clips or small metal objects. Instructions: 1. Wrap the copper wire tightly around the nail, leaving about 6 inches of wire free at each end. Make sure the coils are close together. 1. Remove a small amount of insulation from the ends of the wire using sandpaper or wire strippers. 1. Connect one end of the wire to the positive terminal of the battery. 1. Connect the other end of the wire to the negative terminal of the battery. 1. Hold the nail near the paper clips and observe. What happens? The nail becomes a magnet and attracts the paper clips. Alright, let's dive into the science of magnetic attraction. How does this work? Well, when electricity flows through the wire, it creates a magnetic field around the nail. This magnetic field in turn turns the nail into a temporary magnet, which we call an electromagnet. And you know, the more coils of wire you have, the stronger the magnetic field. Section 6, Experiment 3, Making a Battery from a Lemon. Did you know you can make a battery out of a lemon? This experiment demonstrates how chemical reactions can create electricity. Materials: a lemon, a copper penny or wire, a galvanized, zinc-coated nail, a small LED light and 2 alligator clip leads, optional. Instructions: roll the lemon on a hard surface to release the juices inside. Insert the copper penny into one side of the lemon, insert the galvanized nail into the other side of the lemon, making sure it doesn't touch the penny. If using alligator clip leads, connect one lead to the penny and the other lead to the nail. Touch the 2 leads to the 2 terminals of the LED light. If not using leads, touch the LED terminals directly to the penny and nail. What happens? The LED light will faintly glow. Section 7. The lemon battery, a zesty explanation. The lemon battery works because of a chemical reaction called oxidation reduction. The lemon juice acts as an electrolyte, allowing electrons to flow between the copper penny and the zinc nail. This flow of electrons creates a small electrical current that powers the LED light. Section 8. Electromagnetism, the unsung hero of modern technology. Electromagnetism isn't just about cool experiments, it's the driving force behind so much of our modern technology. Think about it. Electricity generation power plants use giant generators that rely on electromagnetism to produce the electricity that powers our homes and cities. Electric motors. Electric motors, found in everything from cars to washing machines, use electromagnetism to convert electrical energy into mechanical energy. Computers and smartphones. The tiny circuits in our computers and smartphones use electromagnetism to process and store information. Medical imaging MRI machines use powerful magnetic fields and radio waves to create detailed images of the inside of the human body. Section 9. Conclusion. Keep exploring the world of electromagnetism. Electromagnetism is a fascinating and powerful force that shapes our world in countless ways. These simple experiments are just a glimpse into the amazing world of electromagnetism. Keep exploring, keep experimenting, and never stop asking questions about the world around you.